Hello and welcome. Today we are talking about the distributive property. We're going to learn it forwards and backwards. So we have objectives. We're going to learn how to distribute a factor to terms in a group in parentheses. We're also going to learn how to take common factors out of the terms. So the first one's forwards, the second one is backwards. Some vocabulary terms we're going to look at. We don't have definitions, we're going to look at examples. Grouping symbols. Parentheses or brackets work as grouping symbols. Negative terms, in this term, 3x squared minus 2x, the negative term is 2x. 3x squared does not have a symbol in front of it, so we can assume it's positive. Common factors. So 2x squared and 4x are two terms that we have. The common factor between them is 2x. Both of them are divisible by 2x, and we'll talk about that today. Distributing a factor. Here is an easy one, so we'll start off slow. When we have a grouping symbol like this, we have a and b inside, and we're going to multiply the sum of a, b, and c times a, the sum of those two. What we can really do is multiply the a times the b and the a times the c. When we do that, we keep the plus sign, but we get rid of the parentheses. Okay, and just so you know, this kind of goes around the order of operations. It's kind of a ticket around it. And when we do that, we have two new terms, and we got rid of the parentheses. We're going to look at it another way, and just so you know, bear in mind, this is not using the distributive property. The first way we do this is not using the distributive property. Because following the order of operations, we start with the inside of the parentheses. So that's a little different. This is the traditional way of doing it. Order of operations says do the grouping symbols first, so we do that. We have 3 plus 5, that gives us 8. And then we can do the multiplication. So the 4 times 8 is going to give us 32. Now we're going to use the distributive property just to make sure that it works. So we're going to multiply the 4 times the 3 and the 4 times the 5. And we're going to keep the plus sign, but we're going to get rid of the parentheses when we do that. Here's what it looks like. 4 times 3 plus 4 times 5. Order of operations still needs to be observed here. So we do the multiplication first, and then we do the addition later. So we have the 4 times the 3, that's going to give us 12. 4 times the 5 is going to give us 20. Keep that plus sign because we haven't done that yet. And then the 12 plus the 20 is going to give us 32. So we have the same answer. We know the distributive property works now. Here we're going to mix it up. We have variables and regular old numbers. So what happens here? We can multiply the 4 times the a and the 4 times the 2b, or not 2b. Distributing the 4 times to the first term is easy because we can't do anything. It's just going to be 4a. Distributing the 4 to the 2b is a little bit more tricky, but not much, because all we can do is multiply the regular old number 4 times the regular old number 2, and the b just tags along, just goes along for the ride. And that's right, we multiply the two known numbers. So 4 times 2b becomes 8b. b just tags along. Okay, now we can add them. But wait, we can't, because this term is not the same as this term. They are not like terms. And that's because the a and the b are different letters. If both of these were a terms, or both of them had a b tagging along, either way, we could add the 4 and the 8, but they're different. We can only add like terms. Super important that we remember that. Okay, so here is another example that we're going to do really quickly. Now we have a regular old number in both terms. So we can multiply the 3 times the 5 and also the 3 times the 3. And the letters just go along for the ride. So 15a plus 9b. What happens with the negative terms? Same rules of multiplying negatives still apply. So here we have negative x times the difference of negative y and z. The negative times a negative becomes a positive. Negative times a positive becomes a negative. Did I get that right? Okay, so when we distribute it, we got to keep those signs there. This one has a sign in front of it, got to keep it. This one has a sign in front of it, got to keep it. This one has a plus sign. We don't have to show the plus sign there. That plus sign goes there. So it's like the other examples that we looked at. Just remember that. When you are doing this yourself, you don't have to write all of this out. I'm just doing it so that we can see what we're doing. It will be easier for you if you write a little bit less than this, because if you write it too much, you tend to mess up the symbols. Okay, now we can get rid of the symbols. So the two negatives cancel each other out, both become positive. This negative wins over this positive. This becomes a negative. So we have a plus and negative. When we add a negative term, we really are subtracting. So let's just get rid of the plus sign. So it's like these two go to battle, the negative wins. Add a negative term, we are really subtracting the term. And now we've simplified it. This is our original term, so it looks a lot easier to deal with now. It's less intimidating. Cool trick. When you encounter a whole lot of negative numbers in an equation, that's supposed to be equation without an S, multiply both sides by a negative one. So let's look at what that looks like. Okay, so this side of the equation has a lot of negatives. This side also has a lot of negatives. We're going to multiply both sides by a negative 1. We can do just one side. We got to be even. We can do it to both. And really what we're doing there is we're changing all of the signs. All of these negative signs now can become positive. So that's a lot easier to deal with. It's a little less intimidating than that. These don't all have to be negative. There could be some positives in there, but then what happens, they become negative when we multiply them times a negative 1. So that's what multiplying times a negative 1 does. It changes all of those symbols. It changes all of those symbols. Exponents. Exponents make it not harder at all, especially in the early part. So we're going to look at this several different ways. Again, we're only looking at it a special way. We're writing more than we need to write. I don't want you to write this much when you do this on your scratch paper. That would be a waste of ink and waste of time. But we're going to take it apart a little bit. So we're going to look at the exponents for what they are. They're multiplying. We'll start with the a squared. A squared means a times a. A cubed means a times a times a. So we just broke them up a little bit. Now we can distribute the outside term, which is the a. And each one of these terms now gets an extra a. This now has 2, this now has 3, this now has 4. Now we can bring those exponents back. And when we do that, we have a squared plus a cubed minus a to the 4th power. So all we did was add an exponent to we added to the exponent, I should say. That's all we have to do. We can think of it as adding exponents. So we're going to look at this another way. Again, don't write this down normally when you're working out the math problems on your scratch paper, because it would just be too much to write down. But we are going to use it this time. If there is no exponent, we can add one, which will be the number 1. So that just means a, regular old a, we can also just write it as a to the 1st power. When we raise something to the 1st power, nothing happens. It's like multiplying times 1, adding 0, nothing happens. So we don't have to show the imaginary 1 there. We just know it's there. Okay, so when we put it in, it's going to make it a little easier. We're going to add those exponents. We're also going to add those, and we're going to add those. So we can distribute the outside term. It's also important to know this negative sign, let's think of it as going with the a, not with the exponent, because that negative sign is going to stay there. So we're not saying 1 minus 3. We are still saying 1 plus 3. We're always going to add them. That minus sign is going to stay because it goes with the a. Okay, when we do that, we have the 1 plus the 1, 2, 1 plus the 2, 3, and 1 plus the 3, 4. Again, the negative sign stays there. Pretty easy stuff. It gets a little harder when we have regular old numbers, we have negative signs mixed with positive signs, and we have exponents. Now we really just have to watch what we're doing. And the best thing to do in these cases is to go forward in your head, or forward on paper, I should say. Write it out forward, and then do it backwards in your head to make sure that you did it right. Okay, we're going to do it by taking it apart. So we multiply the negative 3a squared times each of those terms, and each of those terms is down here. Now this 2a cubed has a negative sign in front of it. It's got to carry over. Same with this term. It's got a negative. This one has a positive. We don't need to show the positive. We can assume that it's there. So we're going to take all of these apart. So the negative 3, the negative 2, when we multiply two negatives, we get a positive 6. We're going to add those exponents, and the 2 and the 3 become a 5. Remember, that negative goes with the 2. If this 3 were a negative, it would have its own negative exponent. That's a whole new Oprah. We're not going to talk about that today. So just remember, those just add. Okay, over here, same thing. The negatives cancel out. 3 times 3 gives us 9. The a squared and the a to the first, imaginary 1 here, gives us a cubed. And there's no b term here, but there is here, so we have to carry this b down, b squared. And then over here, nothing happens because we're multiplying times 1, so this term stays the same. Now we can put them all back together, and we have 6a to the 5th plus 9a cubed b squared minus 3a squared. I don't think those are in the right order. I think that this should actually go over here because you try to keep the a terms all in one place. But mathematically, it's correct. That's just a matter of etiquette. This is okay the way it is. Okay. We're going to do it in reverse. So we want to do this sometimes to check what we've done, and sometimes this is more useful. In fact, I would say it is usually more useful to factor out a term, doing the distributive property in reverse. So the distributive property, we could say, has been done. Maybe it hasn't really, but we're going to say that it has been done. So each of these terms is now multiplied times an a, and that's what they have in common, is an a. So let's add parentheses and make a the outside term. Here's what it looks like. A plus the sum of all of those. Or sorry, not plus. A times the sum of all of those. So B plus C plus D, all of that multiplied times A. And then in our heads, we can always put it back. A times the B gives us that term. A times the C gives us that term. A times the D gives us that term. Here it's really easy, but later doing it backwards like that will make it, will give us a chance to check it. In this case, it's not an A that they all have in common. It's not a letter. It is a number. They all have 2 in common. So we can take the 2 out of them, and then in our heads we could put it back if we wanted to, and then make sure that we have the right signs when we do that. Here we just have regular old numbers. We don't have variables at all. What we need to do now, we're going to break those down into their prime factors. Well, each one of those is even, so we know that all of them can be multiplied or divided by 2. Some of them more. So this is the prime factorization of them. All of those numbers are prime numbers. Can't break it down anymore. 2 times 2, 2 times 3, and 2 times 5. That would give us those. So all of those have a 2 in common. This one has 2 2's, but the others only have 1 2. Each of these. That means I can only deal with the first 2. I can't do anything with the second one. It's going to stay in the parentheses. I have a single factor of 2 in common. Single factor meaning just 1. Let's make 2 the outside term. And when we do that, we have 2 times everything in parentheses. Okay. Now when we have exponents, we're going to break this down again. Again, don't write all of this down normally. This time we're going to put in our imaginary numbers. We're going to let 1 be the stand-in. So we're going to need a 1 there, 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 and there for all of those that do not have exponents. Okay, now we can see that each of these terms has a common factor. They have a to the first and b to the first. This one has an extra a, but we can only use 1a because these two terms only have the a to the first. Does that make sense? Again, over here, this one goes b to the b squared, but these other terms, we only have b raised to the first power. That's as high as we can go. It's kind of like they all have to agree, and this is what they agree on. Okay, so we can take that out, and then when we do that, we subtract the exponents this time. So instead of a squared, we have a to the first. Here, we're taking the whole darn thing out, with the a to the first and the b to the first. When we do that, it's very tempting to say, well, there's nothing left, it's 0. No, it's not, because really what we're doing is we're dividing it. We're dividing this term times itself, really. This term times itself. And when we divide a number by itself, we're getting 1. So just remember, it doesn't disappear. It does not become 0. It becomes 1. Okay, and then when we divide this term, only the b is left. Okay, and then we take away those imaginary ones. And I recommend don't write them in the first place because it would just kind of confuse you. Okay, this one's a little trickier because we have the negative signs, we have regular numbers, we have exponents, and we have 2 variables. So we're going to find out the common factor between all of these, or the greatest common factor. So we're going to break it apart. And then we can look at the regular numbers. We're going to break them down into their prime factors again. And then we're also going to do something with the exponents. Okay, so we can break the 3 into just 3. It's already a prime number. 9, 3 and 3. 6, 3 and 2. Normally I would say 2 and 3, but it's a little easier for me this time to say 3 and 2 because each of these now has a negative 3. And if I can factor that negative out, usually that's going to be more useful to factor the negative sign out as well and put it on the outside. It's not always more useful, but sometimes it is. And then with the exponents, we just broke them down. The x squared became xx, and the y squared became yy. What do they have in common? Well, it looks like all of them have a negative 3. All of them have at least one x. This one has 2. The others don't. This one has 2 y's. The others don't. So all we have in common is a negative 3, 1x, and 1y. So we can make that our outside term. When we do that, this is what we have when we divide them. We have an x for that first term, so it shrinks quite a bit. We have just a 3 for this first term. It becomes a positive 3 because we're taking that negative 9 and we're dividing it by the negative 3xy. So it becomes a positive. Same with this one. This negative sign disappears. Now it's a little confusing to think of dividing it. Let's think of doing it in reverse. I think for me that is just an easier way to make sure that I did it right, for me to check it. So if I do it in my head, negative 3xy times x, I'm adding I'm adding an exponent, so that becomes x squared. Then we take this term to the middle term, and the negative 3 and the positive 3 become negative y, and then the x and the y go along for the ride. And then the last term, we have negative 3 and a positive 2. That gives us negative 6. The x goes along for the ride. Y gets a friend, so it has an exponent now. So again, just doing it in reverse in your head, doing the distributive property in your head, is probably the best way to check it. For me it is anyway. So did we meet our objectives for today? I think we did. We know how to distribute a factor to terms in a group. So we know how to distribute the a to the b and the c. So that's a times the sum of b plus c. Okay, and we know how to do it in reverse. So when we get this, we can factor out the a. Again, this is usually more useful for the equations and problems that you're going to be dealing with. Thank you. If you have any questions, please let me know and join us next time.